Hey everybody, in this video we'll be solving a system of three equations using Gaussian elimination. Gaussian elimination is performing a series of row operations that lets us solve a system of equations. Let's look at the following steps. Step number 1 is to pick an equation to be equation 1. Usually we want equation 1 to have the coefficient of 1 in front of the x, so we can use equation 1 to eliminate x from the other two equations. And the last step is, from here, equations 2 and 3 should now be equations of two variables. And from there, we can solve for both x, y, and z. Let's look at a following practice. So first we have these following equations, and let's order them in respect to which equation we want to be number 1 and number 2 and number 3. Usually, the order of equation number 2 and equation number 3 is not as important as equation number 1. So we can see that we can either choose the first or second as equation number 1, since they both have the coefficient of 1 in front of the x. But I've just done it as the first equation. And after setting that up, now we can perform our row operations to solve the system of equations. We're just going to write re1 as it is, and then for eliminating the x variable in equation number 2, we'll just simply do 1 minus 2. And that gets us negative 4y plus 3z equals 7. Now, performing the same idea for equation number 3 to eliminate x, we do 3 times equation number 1 minus equation number 3, which helps us eliminate the x and get us negative 5y plus 2z equals 7. So if you're a little bit confused on how to do equation 1 minus equation 2, it's pretty simple. We just get the equation number 1, which is x minus y plus z equals 4, minus the equation number 2. And as you can see, I've distributed the negative sign, so it's negative x minus 3y plus 2z equals 3, which is x minus x equals 0x, and then minus 4y plus 3z equals 7, which is our new equation number 2. Remember that when you're performing row operations and when you're using equations, it's from the very previous one, not the most beginning one. So we're just going to rewrite equation number 1, equation number 2, the most recent ones that we just modified. And to get rid of the z variable, in this case, all we do is multiply 2 times equation number 2 minus 3 times equation number 3. So a little trick to do this is we can see that the least common multiple of 3 and 2 is 6, and to get to 6 from 3 we multiply by 2, and to get to 6 from 2 we multiply by 3. As you can see, equation number 2 has a coefficient of 3 in front of the z, and equation number 3 has a coefficient of 2 in front of the z. So by doing the respective multiplication, we get those z's to cancel out. So now let's solve for x, y, and z. So y is pretty simple because we have 7y equals negative 7, so we get y equals negative 1 by dividing both sides by negative 7. So let's solve for z from our new equation number 2, which gets us z equals 1, and then we're going to plug z and y into the first equation, and we get x equals 2. And the answer is 2, negative 1, 1. I hope this video helped. Comment down below any of the math topics you want me to review. Thank you.